Hey friends, I want to thank our sponsor, Raygun. Are you struggling to replicate the bugs and performance issues that your customers are reporting? Plug Raygun into your web and mobile applications right now and diagnose problems in minutes rather than hours. Kiss goodbye having to dig through log files and relying on frustrated users to report issues. Make your software development life so much easier using Raygun's error, crash, and performance monitoring tools. Every software team can create flawless software experiences for their customers with Raygun. Try it free today at raygun.com. That's RAYGUN.com. Hi, this is Scott Hanselman. This is another episode of Hansel Minutes, and today I'm talking with Dr. Vic Putz. He's a research scientist at QCware. He worked with the United States Air Force Academy. You have amazing LinkedIn, and I'm not going to talk about any of this stuff, even though that would be probably a better show. In fact, what I want to talk to you about is the SpaceOrb360, the greatest controller ever created during the 90s.
Indeed. Thank you very much, Scott, and it's wonderful to be on the show. No, the Space Orb was quite a find at the time. I still regard it as one of the most interesting controllers made in the history of computer games, and it's a bit of a pity that that concept hasn't been picked up on and carried forward. But it still exists today, and yeah, you can still use them.
The Space Orb, now, of course, we're on a podcast, so we can't exactly see this, but you can certainly go out and Google for it. But how would you explain the Space Orb? What does it look like?
It's sort of a curious beast. So we're all familiar, I think, with the gamepad that's sort of become the standard for engagement with computer games these days. But you have to imagine something that's a bit plainer than that, with just a few buttons. And instead of all the joysticks and touchpads and all the other stuff sprouting from it, there was just a big ball. And that ball was the focal point for whatever your avatar in the game would do. If you wanted to move ahead and turn left and look up all at the same time, you would just push the ball in that direction, and that's what you do. And it was really something at the time. I first ran across it to set the stage. This is back in the 1990s. Windows 95 had just come out, and Windows wasn't really an avenue for games, and I just produced a rather bad shareware game called Flynn Sprint, and at any rate, that led me to the Game Developers Conference of 1996, and it's hard to really describe the hope and potential that area felt like. I mean, Blizzard had just come out with Warcraft 2. The folks who did the Flying Toaster screensaver, if you remember that, were there. And then I saw this odd little game controller there, and nothing else was quite like it. This is an era when oftentimes game controllers would be made to fit a particular game. You had an entire series of flight sims, which had fighter sticks encrusted with buttons and switches. You had odd little game controllers, and then you had the Space Orb. It was originally packaged, I think, with a 6-degree freedom game called Forsaken. So 6-degree freedom games like Descent and Forsaken, where you could move in all 6 axes of movement at once, were horrendously difficult to control with keyboard and mouse, which was the standard. And so people tried different things, and the Space Orb was one, to actually navigate through them.
The ball on the Space Orb, I always imagined it as like the head of the person on their neck, and it's almost like you grabbed someone's head and just gave it a little push forward, and then you could twist the head, and like you strafed by basically, imagine if you pushed yourself in your ear laterally. So then you could do strafing, twisting, look up maneuvers, stuff that I don't even know if you could do that today with 2 thumbs. Walk sideways, look up and to the left while turning.
Exactly. It was absolutely dynamite for some games that required that sort of free movement on it. And at the same time, it was horribly flawed. And I think part of that is the reason that it had such difficulty gaining traction. For 6-degree of freedom games, there really was nothing else. But the problem is that this freedom came with a bit of a penalty, and that's that it was actually very difficult to do very precise aiming. And so with so many computer games focusing on targeting and very precise shots, people who were extremely competitive actually didn't like it that much because it was very difficult to line up, say, a sniper shot or something like that. Mm-hmm. So, for example, in Team Fortress 2, which is a very popular online first-person shooter type game. For one thing, you're not using all 6 degrees of freedom to begin with, but for something like a scout, where you're moving quickly, running, jumping, avoiding enemy fire, it was dynamite. I actually got banned from a server at the time for using it, which surprised me, because if I switched to a different class, like a sniper, I couldn't land a single shot. So it was really very on and off, but I found it absolutely fascinating that it was so intuitive in a genre that was extremely difficult to control in other ways. In fact, I had a young friend, a son of a friend of mine, who played Descent recently. He was very into retro gaming, and I had him try it with a SpaceOrb, and he said, this is janky and hard to control, but I feel like this is just how it's meant to be played. And that's exactly the right feeling when you get a controller that matches with what you want to do, is that is the way it's meant to be played. So I rather regret that we don't have that. Well, we do in some areas, but that freedom of trying lots of things, and that everything is kind of standardized to the 2-thumb gamepad nowadays.
Right. And then, of course, there's the mouse and keyboard people that are convinced that WASD plus mouse is the one true way, but it's really the one true way for the sniper, for the precision shot, because your precision is on your mouse. But ultimately, if you wanted to strafe, look up and to the right all at the same time, your strafe is a binary thing. Your movement of, I'm either going to the right or I'm not, because I'm using the D button on the keyboard.
Right. And this was extremely, it was very analog. So you could do all of those things with a certain degree of elegance once you got the hang of it. But there was this learning curve associated with it. And I think that learning curve, it was very difficult to isolate movements. At first, when you were using it, you'd try and move forward and you find yourself flopping left and rolling over at the same time. And I think that threw gamers a lot as well. People liked the ability to jump right in and start going. So, yeah, there was a certain amount of learning involved, and there still is, to be honest.
Yeah. It feels to me like we have almost, I would say, settled. It's that we've picked the most generic thing, that the 2 thumbs is the one that's generic. Like a couple of days ago, I finally received my modified N64, where I added an Ultra HDMI. So I have an N64 with an HDMI port now.
Nice.
So I was playing Perfect Dark. And the only true way to play Perfect Dark is not with one of the janky single thumbstick N64 controllers, but rather with 2, one in each hand, thereby simulating the didn't exist at the time 2 thumbstick controller. It's kind of sad that there aren't different controllers for different games. Otherwise, we'd have a diversity in our choices.
Well, in a way, yes. There's a branch of linguistics, relative linguistics, which posits that you can only think thoughts that you have the ability to express in language. And whether or not you agree with that, I think that's definitely the case for controllers. If you've got a wheel and pedals that you use for driving a car, you won't even think about the things you could do flying a plane with them. And so I feel like the fact that we have standardized on basically the 2 thumbstick gamepad is a boon for economics and game consoles everywhere, but it does restrict the things you can even think about doing in a game. What a minor diversion, I'm playing with virtual reality now, and I think it's very fun to see that just a change in controllers and behavior changes the kind of games which are made. You've got 2 things that look like, feel like swords, so you have games like Beat Saber, or you have endless archery simulators, and that's different entirely, I think, because of the controller and the perception. So it's fun to think of what games would have looked like if something like the SpaceOrb had really taken over and lasted.
Mm-hmm. But like I have, I'm very lucky and blessed to have an HTC Vive, which has those controllers, and they're lovely. But then I also am looking at a Windows mixed reality, like kind of a lower end virtual reality set, and while it has that stick, the bottom part of the lightsaber, ultimately it's just 2 buttons, a trigger, and there's that thumbstick again. So they've taken an Xbox controller, split it in half, and now you hold each half, basically. So there's a lack of creativity there. So then you're saying that would influence indirectly, without even realizing it, the mind of the developer, so that they design to that constraint, maybe even though they don't know that they're doing that.
I think it definitely does. Now, one of the nice things about things like the Vive and other headsets nowadays is that you can still use a gamepad or other controller. And one of the most mind-numbingly nauseating experiences I've had recently was actually playing Descent Overload, which is a rewrite of the original Descent, in virtual reality using the SpaceOrb, which was a really peculiar experience, marrying these old games of the mid-90s with the most modern technology and display. And it was surprisingly effective, actually. It's still great fun. And so it's fun that the controller and the game, honestly, is still relevant after Oh, goodness, 20-something years.
hmm and also, there's a lot of innovation happening with things like the Xbox accessibility controller, which could
Right.
theoretically be used by someone else who's not differently abled. We could use that just like we use Rock Band controllers.
Yeah, it's I've come to think of myself as a bit of a patron saint of abandoned controllers because my workshop is just littered with old things like the Novent Falcon, which was a haptic controller that was out for a while. I've wired up an exercise bike to be a keyboard and control different games, and I love the play of that. That just changing how you interface with something affects how you enjoy it and what you think of doing with it.
hmm
Which is probably the reason I've kept the SpaceOrb on a bit of life support for quite many years at this point.
One of the greatest game controllers ever made, and certainly an utter and complete waste of plastic, is the legendary Xbox Steel Battalion controller, which is basically an entire dashboard. I mean, the thing is like 3 feet wide, and
Oh,
every
yes.
button means something. Like literally every button works. They didn't just say, "Here's 2 joysticks and some plastic." They lit it all up. But it's a huge waste, and now you find them at Goodwill, which is just sad.
It is. And actually, it's at junk stores like that that I found a whole lot of space orbs or very similar devices. So the orb itself wasn't a game controller. It was intended for that purpose. But there was also a variant, actually, I think, for the PlayStation 1. And there were a number of desk-mounted versions, which were primarily used by the CAD community. You could hold your model, if you will, using the orb and move it around and look at different things, and then use a mouse to do manipulations to it. And those actually had worked surprisingly well as game controllers as well, because now you can have your coarse movement in one hand and your fine movement with the mouse for aiming in the other. What you then lose is the ability to flail at the keys and select weapons or do other actions. But that combination actually works surprisingly well. So I don't think just, even though the orb itself has kind of, well, it's in suspended animation and we're keeping it alive in some ways, that idea that you can have 6 degrees of freedom in one control surface is still, I think, alive and well.
I've got both a SpaceOrb360, the original game controller that I got on eBay, as well as the larger space, what is it called? The long one that's almost like a forearm that you use for CAD. What is the name of that?
Well, there were a couple of different models. The Spaceball 4000 was one, and the 5000 looked very similar.
I have one of the thousands, one of the big professional one. These are not made. Is that correct? The company is gone?
3D Connection, I don't think makes them anymore. There was another company, Magellan, which made the Magellan Space Mouse, and I don't remember if they still exist either, although they might.
Right. 3D Connection has these kind of like balls or knobbies, like almost like the volume controller on your old style stereo.
Yes, I've seen those.
Right, and they're basically just a knob, and then you can pull them up.
Yeah. So it's a similar idea, but to me, I think it wouldn't feel quite as nice. I'm not sure. I've not used one yet.
Indeed. So the SpaceOrb 360 had a 9-pin serial port at what, 9600 BPS?
Yes, it was 9600 and it was serial. And it's probably a little difficult to imagine for a lot of people who did not live through that, what connecting something to a computer was like back then. Because this was before the universal serial bus. You didn't even have USB. There were specialist controls or plugs for joystick ports, and anything more advanced had to communicate over this serial bus with this massive 9-pin serial connector, and that's what the Orb chose to do.
And was that enough fidelity? I mean, we have systems now, and every Xbox controller is a full computer that has to have firmware updated, and they send stereo and video and all kinds of context and information. Is 9600 BPS serial enough for 6 degrees of freedom plus buttons?
It is, when you're just doing the input and you're not carrying all of the other information. The protocol that they used was actually kind of complicated. And they had different settings that would tell you different things about it. And there were different response curves so that if you pushed it a certain distance, that proportionally would get you more or less of an output than at the center than it would at the edges. So that you had a little bit of freedom in the middle. But the real Achilles heel, I think, of it wasn't just the complication of learning to use the silly thing, but there were only 6 buttons. And that you run out quite quickly, especially in a modern shooter, where even the shooters back then, first-person games and such, you'd have a number of different things. You'd want to choose different weapons. Descent, for example, you had a key for the map and a key for a different weapon and a key for a different rocket and a key for this and a key for that. And if you had to hold the thing in one hand and grab the ball with the other, you really ran out of inputs very quickly. So that was another little problem that it had, that nowadays I think people expect, and Microsoft has encouraged this a bit with the X input API, they expect a Xbox style controller, and they will use every input on that, and they figure that's all the inputs they have, so they won't bother with more. But at the time, people would just design games for as many keys as they thought people could humanly press, and if your controller didn't have enough buttons on it, well, so much the worse for you. So it was a bit of a mismatch there as well.
Actian Zen Database is the best-in-class, single, secure, scalable architecture for edge data management. It's the perfect solution for software developers who want dedicated application data management and deliver business-critical products and services into OT and low IT environments. Customizable installation, self-tuning, seamless backward compatibility, minimal memory requirements, and exceptionally low support requirements. And better performance than most alternatives like SQLite, all means that you can deliver applications to customers at scale across a wide range of platforms. With direct access from C++, Python, and other popular languages, Zen's simple set of APIs significantly expands the pools of developers capable of building their next business-critical application on Actian Zen. Try it today at actian.com/Zen. That's actian.com/Zen.
So I wrote a blog post in September of 2010 where I discovered a website called jcrow, crow with an E.com, and he still runs, it's Birdman's SpaceOrb message board. So this is almost 10 years ago, 9 years ago, and there was discussion there about a mapping between HID, or Human Interface Device, kind of standards at the time, 10 years ago, and the SpaceOrb. And Arduino was, I think, just getting started. So you could buy an Arduino and do cool stuff with it, and then put on top of the Arduino a hat or a what was the word for those? The Arduino.
They call them the shields for some reason.
Shields, yeah. So you put a shield on top, you plug your serial port into one side and your USB into the other side, and you bridge the old and the new. You bridge the 90s serial port world, the 9-pin RS-232, with DirectX and direct input. This is 10 years ago you were doing this. How in the heck did you pull this off?
Well, that journey started even earlier than that. When the problem with old controllers is, of course, the companies go defunct or abandoned them. And so I used my SpaceOrb for quite a while until Windows XP kind of started giving up the ghost. Actually, it was, I think, the arrival of XP that broke the driver. And at that point, I thought, well, I'd love to use this thing, but I don't know how to use it. So I will write a Windows driver. It was very imaginative of me at the time, because it turns out driver development is an extremely painful little subset of software development. And particularly when you're mucking about in protected areas like you do with drivers, you can trash hard drives, you can do terrible things to your computer. So after flailing at that for a while and having the APIs change with different editions of the operating system, I said, what I'd like to do is just bridge directly to a USB controller, a human interface device. Mm-hmm. And in fact, what I was doing essentially is writing a hardware driver where you'd plug in a DB9, you'd have software on the Arduino, a microcontroller, which would parse the input and spit out an event stream. And then you could map that event stream to arbitrary human interface device actions. And so what happened is you would plug this thing in, and the Arduino would communicate, as it had a native RS-232 serial type communication. So it would load things from the orb, and then it didn't have a very good USB output. So we would emulate that by a piece of software, which I borrowed from other folks, all praise open source. And it would just kind of bit bang manually turn lines on and off to send the signals over USB. And lo and behold, it was a strange thing, very manual and very error prone. So
it sounds like very timing specific and timing prone.
Extraordinarily so. But at the end of the day, it all worked. And you could plug it in and it would show up on your computer as a 6-axis, 16-button game controller. Mm-hmm. Now, the 16 buttons was a bit of a stretch. This is actually still the question I get the most when people start using this is, why don't the edge buttons work? So, again, hard to imagine this thing, but you can imagine holding something that looks a bit like a crescent shape. And on the face of it, facing towards you, are 4 buttons, and on the edge where your index finger would lie are 2 more. And I thought one thing that really frustrated me was that problem of running out of buttons earlier, so I would try chording. So the 4 face buttons, right, would be on different pages. And you'd have 0, 1, 2, 3, or 1, 2, 3, 4 if you don't start at 0 like normal humans. And you'd press one button, and then you'd have 5, 6, 7, 8, press another button, 9, 10, 11, 12, and press both of them together, and you'd have up to 16. So you had 16 virtual buttons. And once you got the hang of it, that actually worked surprisingly well, because then you would think maybe thematically the front page buttons were for firing weapons in the game or whatever. The second page buttons might be for selecting weapons, that sort of thing. And then the fun only got more, because if you're already emulating a human interface device, it's only a step from there to say, well, it's not just emulating a joystick. You could also make it emulate a mouse or a keyboard. And that was a very fun rabbit hole to drop down, because after a while, it got to the point where you could assign axes to keyboard buttons or mouse movements and get control from this thing in games which never even imagined being controlled by a joystick, much less a ball on a gamepad. So a very fun project, and it demanded a fair amount from me. My software development background had not included microprocessors up to that point. And I thought, well, this is it. I think we're done. And alas, it wasn't the case. We actually, I envisioned that as a kit, because I kind of grew up in the era of Heathkit, which is this wonderful company which had a motto, "We will not let you fail." And you'd buy a kit for building a radio, and you'd learn how to build a radio. So I made little kits for these orb shields and a couple of the follow-ons. But more often than not, people just wanted to actually use their old device without learning to solder things together and write software. So I thought something a little more user-friendly might be in order. And it's still not terribly user-friendly, but we moved from having an Arduino, which you would purchase, and then the shield, which you would purchase and stick on top, to actually trying to manufacture an all-in-one device.
So who does that, though? I mean, here's the thing. There's all these people on the internet, and we talk to them all the time, and they have all these amazing ideas, but so rarely do they do it, though. You had an idea. I've had lots of ideas. I have about 30 registered domains that are all a monument to my failure to execute. You actually not only writing software is easy, but then making unsigned drivers and then drivers for Windows Vista, and then making a board, making instructions, and then creating the boards. Like, this is a hobby? Is your spouse okay with this? How do you execute and ship physical stuff when it's not a business?
I will tell you, not very efficiently. My wife actually is very much okay with it. In fact, when she learned about it and saw what we were doing and learned how to put things together, she actually became much better than I am at soldering the silly things.
That's awesome.
Yeah, it is. She's absolutely delightful. The manufacture actually took a long time, and it mostly came from this. Of course, we all know and love open source software, but open source hardware is quite a movement as well. And so the Arduino wasn't just a nice thing you could buy and take home and play with. The specifications are online, the schematics are online, so you quickly could see, oh, well, this is just a bunch of parts, and I could assemble them together. And if I only knew how to create a circuit board, then that would happen. And so I learned how to create circuit boards through a really, really primitive process of photocopying schematics onto magazine pages and then ironing them onto circuit boards and etching away, which was not the way you really wanted to do it, but I learned. And then with the advent of kind of the hobbyist electronics era, a lot of circuit board shops, proper fabrication shops have cropped up where you can send away a design and get boards back in just a couple of weeks. And this takes a while. I love software because you can type a new thing and you'll get the results instantly instead of trying something out and getting a prototype back in a couple of weeks. But it did work. But hardware is painful. It's extraordinarily frustrating. In the world of software, you never write a program and then have to say, "Oh, I'm afraid the for loop didn't really work out on that one. You're going to have to tune it up." You modify it, but there's not a gap between design and manufacturing in many ways.
Right.
And with hardware, especially small-scale batches, The tools and techniques you have to use are almost comical. So when I first started producing these, I was on an assignment in London. And the way you'd lay things out is you'd put a stencil down and you'd smear soldering paste all over and get through the holes in the stencil. And soldering paste is just little blobs of solder floating in flux. And you'd take this and you'd delicately put all of your little, bite-sized components on. Some of these things are as small as a grain of rice, the little resistors and capacitors and such. And then I would literally cook them on a $30 hot plate that I bought from Target and turn up the heat until I could see the solder melting, and eventually it would coalesce, and then you turn it down and pull everything off. And then you'd start testing and find out what everything didn't work. And traces might be bridged or things might need to be moved and modified. So it's really fairly painful to actually get through. And if you're not careful and you let things sit too long, for example, this latest batch, solder paste sat too long and it didn't spread very well. And out of 8 boards, we've only got 1 that came out cleanly and worked from the beginning. All the rest are going to need rework. So I hate hardware. But there's something really nice that is different from software in that you get a physical thing you can hold in your hand and plug in, and it'll light up or communicate and do something. And that's really engaging, which is one thing that keeps me coming back to controllers and small electronics project, because I just think that's absolutely wonderful.
And I bought an Orb shield and I put it together, and I've got it. I'm looking at it right now, and it sits on top of an older Arduino, and it looks big and things are spaced far apart. And now I'm looking at the new Thingotron, which is amazing. What is it called? The Thingotron 9000?
So the Thingotron's actually the company name, or I should say the self-propagating hobby name.
Orbotron.
It's the Orbotron 9000. For a while, I foresaw a bunch of different little devices that would all end in Otron because I just thought it was hilarious for no apparent reason. There was the Kettletron, which was a temperature controller for tea kettles, electric kettles. There was I can't remember, I was putting together another small amplifier, things like that, because I thought it would be fun for people to have kits. Right now, we're a little divorced from our electronics in a sense. A phone is a magical black box, and you don't really know what goes on in it. And I thought it would be nice to have small kits of different devices that people could open up and tinker with and put together. And alas, I ran out of time and also had a child. Both of those things happened in close proximity.
It's funny how those things happen, and then one project replaces another, where
indeed
the baby replaces the Orbotron. I'm looking at a picture of an Orbotron here, and it's small and stylish, and it's got that lovely. It is literally. It probably could be even smaller, but it's limited by the size of the 9-pin serial adapter on the side there.
Right. The serial adapter takes up the bulk of the board. And nowadays, instead of this giant Arduino, we have a very small, flat packaged AT-SAM D21 chip with a ton more memory and a ton more speed, which we don't entirely need. And the only other thing that's really on the board chip-wise is a small RS-232 adapter, because the Orb did a couple of different things. It communicated at a much higher voltage than you want to have on a small USB-powered board. So that little chip adjusts voltage levels and handles the serial communication. And then the only other components on there are a bunch of little capacitors for voltage smoothing and voltage adapters as power sources. So you're right, it could actually be even smaller. The two limiting factors are the plug itself, which is this big old 1990s era serial port, and my ability to place things with tweezers.
And how do you firmware flash this yourself? Like, if I buy one someday, in a perfect world, does it come with code that you've added, and then is it updatable?
Yes. So this basically is an Arduino. This is adapted from the wonderful Adafruit, one of their boards with a similar processor, and so it runs a very similar firmware. And it is actually programmable from the Arduino IDE. And the idea was that was how you would modify it and map things to different control surfaces and send out keyboard commands as you'd write a separate program and upload it. And it does work smashingly well for me. And other folks seem to have a little bit of a hard time with it. And I'm not sure if it's a device driver issue, but yes, it is actually quite adaptable and reprogrammable. I do flash it here with a hardware flashing device. I don't know what else you would call it. But it's ideally just flashable from the USB port. You load up the Arduino IDE, you can still send code to it. And what I'd like to move toward, one of the new trends, I think, in the small electronics like Arduino is languages like CircuitPython, where you just write code, drop it right on the device as if it was a flash drive. It just shows up as a storage device, and then things run. I think that would be a lot more convenient because, honestly, the difficulty of setting up the Arduino IDE and downloading the extra drivers for the board and getting them to talk nicely has been a bit of a difficulty. But it does work, and I have had folks say that it works actually very well, and I've had others that never quite managed to get it to work. And in the programmability side of things, it always seems to work as it stands, plugging it in and getting a game device out of it.
As I look around on the internet and Google around for orbs and Orb Shield and SpaceOrb, I find unfortunately, just a littered mess of broken domains, people over the last 10 years doing this, but there are still those of us, myself included, who are passionate about making this happen. Here's the question. Is it just you and me left? Or are we talking, there's dozens of us, what are we looking at here?
Well, I often wonder that myself, and I sort of say, this is an awful lot of effort, just onesie-twosie-ing these boards out. Because, if I knew we were going to have hundreds of units sold, it would be worthwhile to pay for someone else to assemble them, and they'd probably be a lot nicer and smaller and prettier. But when I make a batch of 8, 16, something like that, they'll trickle out over a period of a couple of months. And every time I threaten to stop making them, my wife says, yeah, but you always sell every batch. So, yeah, there are actually quite a few people who still want them, and they're surprisingly spread around the world. We've had buyers from Australia, various countries in Europe and the UK. And so there are orb lovers basically around the world, and surprisingly many of them still interested in using it.
Well, I hope that we find them. I hope that this podcast educates the people, not just the people, but also the young people who should immediately go to eBay and find themselves one of these. Because I think it is just a joy, but I'm also a big fan of history, remembering our history and being able to keep that history alive. And I love that you're doing that with open source hardware and software, and that you didn't just make a custom board and make it totally non-programmable and closed, that you used Arduino pieces. Because it in itself, if you go away, the Orbotron 9000 could live forever.
It could indeed. Even the design of the board is online at a GitHub repository. I'll send you the link.
Oh, fantastic. Thank you so much, Dr. Vic Putz, for talking to me today about the world's greatest game controller, the SpaceOrb360 and the Orbotron 9001. This has been another episode of Hansel Minutes, and we'll see you again next week.